Okay, so this is lesson 2.4 from Mrs. Cucci's College Now Pre-Calculus class. And today we're going to be talking about symmetry. By the end of this lesson, you will be able to determine whether a graph is symmetric with respect to the x-axis, the y-axis, and the origin, and determine whether a function is even, I should say odd, or neither. Okay? So that's what we're going to do today. Now, new concept, even odd and neither, so please pay attention. Okay, so symmetry occurs very often in nature and in art. For example, when we're talking about animals, mammals, people, we're kind of symmetric. If you think about looking at someone's face, each eye is usually symmetric to the bridge of the nose, your eyebrows, your cheekbones. Even with your shoulders, they seem to be equidistant from the center of your chest and so on. When you cut open an apple, if you look at an apple, when you cut it open, the seeds seem to be symmetric. So there's a lot of times we see this occurrence in nature as well. So let's think about the points 4, 2, and 4, negative 2. Both of these points lie on the graph of x equals y squared. Points like these have the same x value, but opposite y values, and we call them reflections, okay? This shows a reflection over or across the x-axis. So we come up with this general rule. For any point that we want to reflect over that x-axis, we say that the original point xy becomes the point x negative y. So essentially all we're doing is we're negating that y value, okay? We also said that the graph is symmetric with respect to the x-axis, is how we would say it mathematically. So again, our rule being from xy to x negative y. Okay. Very similar to that, if I have the points 3, 4, negative 3, 4, they have the same y value but different or opposite x values. This is also a reflection, but it's a reflection over the y-axis. So the rule for that, xy, becomes negative xy. So essentially we're just negating the x. So reflect over the y, negate the x. Reflect over the x, negate the y. Okay? Mathematically we say that it's symmetric with respect to the y-axis. And one more that I need you to know, and that is a reflection over the origin being the point 0, 0. Okay? So if I have negative 3 and the square root of 7, that reflection over the origin becomes 3 negative square root of 7. So my rule there is xy becomes negative x negative y. Essentially, we are negating both the x and y. Okay? This is also considered symmetric with respect to the origin. So visually, what that reflection over the origin is going to look like is it's going to look like a rotation of 180 degrees. Okay? So, recap. Rotation or reflection over the x-axis. Okay? xy becomes x negative y. Reflection over the y-axis. xy becomes negative x, y. And reflection over the origin, xy becomes negative x, negative y. Okay, so those are the three that you kind of have to have memorized. So you should have those down pat. And you guys learned that in geometry in 10th grade, so that shouldn't be anything new. Okay? All right. So we do have some algebraic tests for symmetry, and that's kind of how we're going to deal with them. If we want to test for symmetry in the x-axis, what we do is we take y and we replace it with a negative y. If it produces an equivalent equation, then the graph is symmetric with respect to the x-axis. We follow that same procedure with the y-axis and the origin, except we follow our rule, right? The y-axis, we replace x with negative x. The origin, we replace x with negative x and y with negative y. If those produce equivalent equations, then that's where you find that symmetry. Okay, so let's look at one. We're going to test y equals x squared plus 2 for symmetry with respect to the x-axis and the y-axis. Let's start with the x-axis. Okay. If we're checking for symmetry with the x-axis, we're plugging in negative y for y. So we get negative y equals x squared plus 2. Is negative y the same thing as y equals x squared plus 2? Well, no. Okay, so this one is not symmetric to the x-axis. So let's test it for y-axis. To test y-axis, we put in a negative x for x. So we get y equals negative x squared plus 2. Negative x squared essentially means negative x times negative x. And we know that a negative times a negative is a positive. So now, is this the same as this? Yes. Okay, so we can say that y equals x squared plus 2 is symmetric to the y-axis. Now, if we want to test it for the origin, we have to replace it for both. So, negative y equals negative x squared plus 2. We get negative y equals x squared plus 2. So again, that's not the same. So we're going to say that it is symmetric about the y-axis. So that's how we test for these things. It's not difficult to test them. You do need to know your rules of exponents and be careful of how you're working with it algebraically. Okay, so let's look at the next page. We're going to try this next one, and we're going to test this for symmetry with the x, y, and the origin. So again, let's start with the x-axis. And we're going to plug in, pardon me, negative y for y. So we get x squared plus negative y to the 4th equals 5. X squared plus, now negative y to the 4th. That means a negative times a negative times a negative times a negative. We know that if it has an even power, it comes back positive. Okay? Is that my original? Yes. Okay, so we can say it's symmetric about the x-axis. Let's try y. We're going to plug in a negative for x. And we know negative x squared becomes a positive. So this one is also yes. Okay? So now we know it's symmetric about the x, it's symmetric about the y. And lastly, let's talk origin. We're going to plug in x and y. And we get x squared plus y to the 4th equals 5. So this is also a yes. So this function is symmetric about the x-axis, the origin, and the y-axis. It can have multiple symmetries. Okay? So keep that in mind when you're doing these. Don't quit when you find one that's symmetric. Okay? Okay, so this brings us to even and odd functions. If the graph of a function f is symmetric with respect to the y-axis, we say that this is an even function. So again, symmetric to the y, even function. So that's to say that if I plug in that negative x for x and I get back my original, then it's an even function. Okay, the rule being f of x equals f of negative x. If it's symmetric to the origin, we say that that's an odd function. Okay, so the rule for that is f of negative x equals negative f of x. Okay, so essentially negative y, negative x. All right, so here's what you need to remember. Even, we plug in negative x. Odd, we plug in negative x and negative y. Okay, so negative x is even, and that's symmetric to the y-axis. And then odd is symmetric to the origin. Okay, so let's give this a peek. We're going to determine if it's even, odd, or neither. I always tend to start with trying to determine if it's even. You always have to start somewhere, right? To determine if it's even, we said that we're going to plug in a negative x. So we want to know, does f of x, does f of negative x equal f of x? That's the question. Okay? So we're taking f of x and we're saying, all right, we want to find f of negative x. So everywhere we see an x, we plug in that negative x, and we see what we get. So Negative or odd exponent means I keep my negative. Odd exponent means I keep my negative. Okay, so here's what I wind up with. Is f of x, is it equal to f of negative x? Is this the same as this? No. Okay, so we know it's not even. So let's check for odd. Okay, so the question for odd is, does negative f of x wind up equaling f of negative x? Now remember, this is f of negative x. We already found it. It's right here, okay? So we want to know if multiplying my function by negative will give me that same solution. So negative times f of x equals negative times my entire polynomial. So we're going to distribute that through. So does that equal f of negative x, which is what we already found? This is why we do even first, okay? So does this equal this? Yes. So this function is odd. Now, if it didn't work, what we would say is that my function is neither. Okay? We're going to do quite a bit of practice with this. And again, this is something new you haven't done before. All right. Next page. Okay, so we're going to determine if h of x equals 5x to the 6 minus 3x squared minus 7 is even, odd, or neither. So again, we always start with figuring out, is it even? We plug in that h of negative x. Okay, so 5 to the negative x 6, 3 negative x squared minus 7. And we get even powers, which means it becomes positive. Is this equal to this? That's our question. Okay, if we look back at our original, is it the same? Yes, it is. So we can say it's even. So like I said, we're going to do quite a bit of practice with that in class, so be prepared with any questions that you might have. And that's it, guys. Thank you. Bye.